can tell you're bored, so it's time for geometry. All right, here we go, guys. Lesson 26.4, we're on page 35. We're still talking about similar solids, okay? Similar three-dimensional shapes. All right, look, they gave you this baby here, okay? I hope you know that is a triangular prism, okay? Triangular prism over here, okay? All right, we're gonna take their scale, their surface areas, and we're gonna come up with the scale factor, okay? So, what am I trying to say in English? You're gonna take the surface area, they gave it to you, of the larger one, and you're gonna create a fraction, you're gonna set a ratio, and set it to the surface area of the other one. For a scale factor, all you're gonna do is set up as a ratio, there are two surface areas. Then you have to reduce it. You always simplify your fractions, okay? The largest number, at first I was thinking 5, but then I was playing around with it, and 15 is the largest number that can go into both, because I want to reduce it. So I'm going to go 960 divided by 15, and I'm going to get 64. Then I'm going to go 375 divided by 15, and I'm going to get 25. And if you get a little worried about this section of reducing fractions, remember you have an ABC key, okay? Most of you do. You can type in 960 ABC 375, you have to hit equals, then hit Shift ABC key, and it will give you this right here as the scale factor. Your calculators will reduce. Either way, 64 over 25 is going to go for, for the surface area. I put it in the wrong spot. I got to wake up this afternoon. The reason why it goes here, remember I was doing surface area versus surface area. I reduce it and I put it there. Okay, now that I have the ratio of the surface area simplified, how do I back it up and go scale factor? That's a really good question. Remember, if you know the scale factor is A to B, and now you want to do the ratio of the areas, it's going to be A squared B squared. All right, this is where we're starting then. This A squared B squared is this surface area ratio. So we've got to undo this squareage. So you know that's the square root. So we're starting with the ratio of the surface areas. Now we got to square root the top and bottom. All right, so the scale factor is going to be 8 to 5. So you're going to put 8 to 5. All right, let me make sure I unconfuse y'all, okay, because I think I confused myself there. All right, they gave us the surface areas. We create a ratio. We reduce the ratio. Because it wasn't the parts, because it was the area, I've got to put it in the surface area ratio. And then I got to go backwards and hit the square root button on both of those to get that 8 to 5ths, okay? Ooh, I have an idea. Wait. All right, think about it. If I had told you right off the bat that the ratio of the heights, okay, of these prisms, if I said, hey, the ratio of the heights of those prisms was 8 to 5, I said, what would be the ratio of the areas? You would go 8 squared over 5 squared, and you would get 64 over 25. You would get this second ratio. We're just giving you the second ratio first, and then you're going backwards by hitting the square root. We're good? Okay, go back to the scale factor, which was 8/5, right? Now if you want volume, all you do is cube that top baby, cube that bottom baby. Remember, that's 8 times 8 times 8. This is 5 times 5 times 5. I'll do the easy one. I know the bottom is 125, okay? Can anyone tell me what 8 times 8 times 8 is? Anybody? Okay, I heard it. 512. All right, so your ratio of your volumes is 512 to 125. All right, let me hit the brakes for a second. All right, again, we're still doing the same situation. Ratio of the parts, then ratio of the surface areas, and then ratio of the volumes. Wait, what's that? You're bored again? Oh my goodness, you guys, stop being bored. Fine, I'm going to find you one that has words then. You know when y'all are bored, I got to kick it up a notch. All right, I think that one was just too easy for you. You're sitting back going, I need a slight challenge. And I'm hoping this number 9 is going to be a challenge. You know what's going to be a challenge is how long it takes me to put this baby in focus. All right, here we go. So number 9, I see English. All right, let's hide number 11. All right, I erased. By the way, this is lesson 26.4. Oh, and one more time, it is geometry. So if you're in algebra 2, get out. No, kidding. This is geometry. If you want to watch it, I mean, if you're that bored, okay, anyway. All right, solid A is similar to solid B. Exciting. The ratio of the height of solid A to the height of solid B is 7:3. Okay, so this is parts. Height is parts, linear measurement. Okay, so the ratio of the height of solid A to the height of solid B is 7:3. Okay, so right off the bat, who's the larger solid? Yes, solid A is going to be larger because it was ratio of A to B. Solid A to solid B, so 7 is bigger than 3. Okay, cool. Find the ratio of the volume of solid A to solid B. Oh, this is simple. They want volume. All right, I want you to think, while I was saying cubic or to the third power, you're just going to take your 7 and take it to the third power. You're just going to take your 3 and take it to the third power. All right, 7 times 7 times 7, and 3 times 3 times 3. And the ratio of your volumes, I'm still waiting on y'all. Who can tell me the ratio? What's that? 343 over 27. Very, very, very good. Okay, and in case you forgot, it works this way. If the parts is A to B, then the volume is going to be A cubed to B cubed. Hope this is helpful. It's good to see you. This was lesson 26.4, and we'll see you soon.